This is a video lesson on inscribed angles. First thing we're going to do is review the angles that we do know in a circle, and that would be the central angle. So let's take a look at a central angle. All right, so that yellow angle, that's the separation between these two rays, right? That yellow angle, you can't call it angle O because there's two angles at angle O, right? There's an angle over here too. See, those are two angles at angle O. So instead, we're going to have to call it angle COA. And we know that angle COA is a central angle. And we also know that arc CA, that's this arc from here to here, has the same measure as the central angle, 40 degrees. Okay? So the measure of arc AC or CA, doesn't matter which way you write it, is equal to 40 degrees, as is the measure of angle COA, which is 40 degrees. That was given to us because it's a central angle. And central angles have a vertex at the center. Okay, at the center of the circle. So remember what a vertex is, right? A vertex is the middle letter here. See, this is the middle letter. That's the vertex of the angle. Today we're going to learn about a new angle. Or a new type of angle. It's called an inscribed angle. And the big difference with inscribed angles is its vertex is on the circle, okay? So there actually are a number, well, there's two inscribed angles in this picture. Unfortunately, one of them we can't really find or deal with directly. We will find it in a few seconds, but the main one is this one. This is an inscribed angle. Why? Because the vertex is on the circle. So the name of this angle would be, and I'll put it over here, angle CBA. Angle CBA. That's an inscribed angle because its vertex, which is B. Remember we talked about this. The vertex is the middle letter. See? The vertex is on the circle rather than at the center of the circle. So back here with our central angle O, that's COA. This angle here has a vertex at the center. Inscribed angles have a vertex on the center. There's another inscribed angle over here. The problem with this inscribed angle, nothing wrong with it actually, and that's its vertex. And here's its rays. It's just that it doesn't intercept the circle, and you're wondering what that means. So let's talk about that right away. Back to our central angle. Angle COA, this angle intercepts the circle. See, it hits the circle. If you imagine the rays are arrows like we usually do. These are rays extending, those are arrows. And the arrows pierce the circle at points C and A for this angle. And it forms this arc CA. See, arcs are formed when angles, like this one, a central angle, kind of pierce the circle. Their rays pierce the circle. And it creates an arc, right? A piece of a circle. All right, inscribed angles also intercept the arc. So let's take a look at this angle CBA right here, and let's follow ray BC, there it is, and ray BA. Okay, now this inscribed angle also intercepts the exact same arc CA, that we saw a minute ago. Okay? If you look at the other angle over here, this purple one, you can't see where it's going to intercept the circle because there's nothing over here, see? So we're not going to really deal with that guy directly. Right. Even though he's an inscribed angle, he's not going to follow our rules. Okay, so our job today is to discover what is the relationship between the inscribed angle and the intercepted arc. That's this green arc here. So in other words, if that's 40 degrees, we know that central angles are 40 degrees. But we don't know how the arc and the inscribed angle compared to each other. Well, if you look at this 40-degree angle and the central angle, obviously this red angle here, well, no, it's green, but that angle over there, the inscribed angle, is going to be smaller. You can physically see that it's smaller, okay? And the way we figured out is we look at this 48-degree angle, and we know there's a linear pair here, so we know that this is 140. They have to add up to 180. And then we notice that this radii and this radii, so that is segment OC and segment OB, are congruent. That makes this an isosceles triangle that you see here, which means this red angle here and this purple angle here, the purple angle here, and the red angle here are congruent. And if it's 140 degrees and there's two angles that add up to 180 with the 140, that leaves only possibility is 20. Okay? So what happens is this 20 is half of 40, and that's true for all inscribed angles, okay? So inscribed angles are half the measure of the intercepted arcs. Okay, so that means this angle is going to be 20. This angle is 20, but you see, we don't know where it intercepts the circle. If we were to extend this out here, we could then say that this arc is 40 degrees from here to here, but nobody did that for us, so we're really not going to touch that. Okay, so let's go to our first example problem. Now, the word inscribed comes from the fact that this triangle is inscribed inside the circle. So if you remember from your projects, the hexagon and the septagon and the dodecagon, etc., were all inscribed in the circle, meaning their vertices all lie on the circle. So this is an inscribed triangle, which means there's going to be 3 inscribed angles. So here's an inscribed angle, here's another one here, and here's a third one. Okay. Now, it doesn't really matter which one we start with. We're going to start with the 49, but we remember the rule. If you go back to the slide, right, it says the inscribed angles are half the measure of the intercepted arcs. So at this 49 degrees, let's follow its rays. That's ray DB. There's the first ray. It pierces the circle there. Here's the second ray. It pierces the circle here. What does that form? That forms this purple arc. In other words, this arc would be cut off from the circle and fly away or float away if we were in space. This arc would be the intercepted arc, okay? From CV, BC. That's arc BC, okay? And we know that that arc, that the inscribed angle, this 49-degree angles, is half the purple arc, right? Half the measure of the purple arc. Because inscribed angles are half the intercepted arc, half the measure of the intercepted arc, okay? So in this case, we're not given the arc, we're given the angle. So to get back to the arc, we have to double it, right? If 49 degrees is half of some number, that number is going to be double 49. Okay? And of course, you know, but doubling 49 makes this 98 degrees. Okay? So the arc from here, so the measure of arc BC is equal to 98 degrees. Of course, that's not the arc they were asking us for. Okay? The arc they're asking us for is over here. All right, so we could keep going. We could actually use the 70-degree angle here and find this arc and then find this last arc, but there's an easier way to do the problem, okay? That's to find the third angle in a triangle. So you know if you have 70 degrees and 49 degrees, right? Put in your calculator, that should be 71 degrees. I'm sorry, actually, I made a mistake. I don't have a calculator. 61 degrees, my bad. Okay, 61 degrees, but you have a calculator, so you should have gotten that. So 3 angles in a triangle, and this 61 is an inscribed angle, right? So if we follow the 61-degree angle, and we see it hits the circle here and hits the circle here, it's going to intercept this big arc, which is the arc they're asking us for. They didn't really name it, but I know what the name is. That it's the measure of arc DC or CD. That's what they're really asking us for with this question mark. And that is double this inscribed angle because its vertex is on the circle. Therefore, the arc it intercepts will be double its measure. So that's going to be 122 degrees. Okay? All right. Let's try this one. Now I want you to try this one. So just start with this angle P or angle EPD, right? That's this angle right here. And tell me if you can figure out what, that's an inscribed angle. Tell me if you can figure out any of the arcs in this picture. So pause the video, try it in your iPads, and just write down the answer. Okay, for those of you who actually did it, let's take a look. This is an inscribed angle. Its vertex is on the circle. This is the first ray. It intercepts the circle at E. This is the second ray. It intercepts the circle at D. Okay? So the measure of arc ED is going to be double because this is always half the intercepted arc. So the arc's going to be double. So that makes this 100 degrees. Okay? 100 degrees. From here to there. That's the intercepted arc. Okay? But they want to know what EF is also, EF. Now that's very strange because there's no angle, well there is an angle associated with it actually. Right? That angle is right here, but I don't really know that angle. That's an inscribed angle, and that intercepts the red arc. If you were to follow these rays out this way, it would hit it. So we're kind of at a loss, okay, at first, until we realize that this is a circle, and just like from last test, right, let's take a look. There is a diameter. There it is. It's a diameter. It's a chord that goes through the center of the circle, right? Any segment here that goes through the center of the circle hits the circle in two spots, and it goes through the center, splits the circle into two semicircles, right? So that means from here to here is a semicircle, and underneath is also a semicircle. And if that's a semicircle, and that's 180 degrees, and we already know the 100 from our work earlier, that makes this arc 80 degrees from there to there, okay? And if anybody asked us what was this red angle here, I didn't ask you that, but somebody could, so let's actually add that. So the measure of angle EDF, oops, my bad. Measure of angle, look at the difference here. That's an angle symbol, right? We don't use an angle symbol for arcs. So the measure of angle EDF or FDE, we'll do EDF, is equal to what, right? It's equal to what? Well, it's equal to half the intercepted arc. So this is an 80-degree arc. So that makes this 40. Remember, I got the 80 because of this semicircle, the blue semicircle. Diameters, this yellow line always cut the circle into two, cuts the circle into two semicircles, okay? So this one has to be 40 degrees. Okay, so hopefully you got that one. There's a lot of them just like this on the homework worksheet, which is available on the drive, and your teacher probably will put it on a backpack before you go home today, but actually it should be in the drive, and we may have a handout for you waiting as well. Okay, this last type is when there's no numbers given, just letters, and we have to write an equation. We've seen these many times with parallelograms and other types of problems, okay? Well, this is an inscribed angle, so it's very easy, and this is an arc that it intercepts. So we know that if you go from the from the inscribed angle to, right, if we go from there to here, we know we have to double this, right? And if we go from here back to the other one, we have to half it. So you have two choices here, right, to write your equation. You can double the inscribed angle, which is what I'm going to do. So in other words, you could double the inscribed angle measure to equal the intercepted arc, okay? Or, right, or you could half the intercepted arc, because the inscribed angle, 4x, is equal to half the intercepted arc. Okay, now which way looks easier to you? Of course, the one without the fractions, right? Although they're both correct and they both work fine, we're going to do the one without the fractions. Okay, and let's solve this. So if you haven't solved this already, go ahead and do it. Pause the video, solve this, do the algebra, take you about a minute, not even, and then start the video again. Okay, so 2 times 4x is 8x. Remember, you're not distributing this 2. A lot of kids like to think they distribute the 2, but there's no plus or minus here. So you only multiply the 2 times the 4. Okay, equals 5x plus 45. Subtract 5x from both sides. Make sure you're showing your work here. When people don't show the work, that's when most of the mistakes happen. 3x equals 45. We're going to divide both sides by 3. And of course, x equals 15. Okay, but that's not the answer to the question. The answer is, what's the measure of angle ABC? Well, angle ABC is the inscribed angle here, and it's 4 times that number, right? It's 4 times 15. Try it on your calculators. It's 60 degrees, right? And of course, I know AC without even plugging it in, although I can plug it in. It has to be double that, so it's 120 degrees. Although it's a good idea to plug 15 in for x here, so multiply 5 times 15 and add 45, to be sure you get two numbers that are double each other, right? Or one number is half the other one, or the other one's double. You know, the 120 is double to 60. So it's a good way to check your work. And I think that's all the problems we have. Okay, so go ahead and do the homework worksheet for the rest of the class period. You can refer back to the video to look for similar problems. There are plenty of similar problems here. Remember to be careful for diameters. So anytime, like in this problem, you see you have a segment going through the center of the circle, you know that you can use the 180s from the semicircle. So that's going to happen a lot in your homework. And of course, there'll be some variable problems like this. So watch this example again to help yourselves out. Okay.